Assalamualaikum warahmatullahi wabarakatuh. My name is engkuuu bin Zamrin and I'm from DLI 5A. Today I'm going to talk about a Scada, or known as a supervisory control and data acquisition. So thanks to my lecturer Encik Ismail bin Yaakob for giving me this opportunity to present uh, to my lecturer. So first thing of all, introduction. Scada, or known as a supervisory control and data acquisition, is a control system architecture that uses computer network data, communication and graphical user interface for high-level process supervisor management, but use other peripheral devices such as programmable logic controller or known as PLC and discrete PID controller to interface with the process plant or machineries. And second, this is a example for manufacturing process for SCADA. As we know, they have four levels for the manufacturing uh, process. Level 0 that we know contain uh, the field device such as flow and temperature sensor and control elements such as control valve. And level 1 contain the industrialized input or output modules and their associated discrete electronic processes. And the level 2 contain the supervisory computer, which collects information from the processor nodes on the system and provide the operator control screen. And then for the level 3 is the production control level, which does not directly control the process but is cornered with a monitoring production and target. And lastly, for the level 4 is the production scheduling level. So next we go to the SCADA function in oil and gas industry. The SCADA function in oil and gas industry, that is alarm, status messages and meter reading from remote plant such as pipeline, pump station, production station, terminal, to remote control room. Secondly, set point control of local controller from a remote control room. Thirdly, shutdown command from remote location to local ESD system. And then relaying of alarm and shutdown messaging to roving operator. Then daily reporting, well test reporting, operator guidance on optimizing via dedicated application program. Then you have a system architecture. The SCADA system typically contain different modules such as control room, OPC server, data logging system, SQL database, and alarm system. So as you can see, these all of the different module that we got from here. And then this is a supervisory computer. Supervisory computer is the core is a core for the is a core of the SCADA system, gathering data on the process and sending control command to the field connected device. Secondly, it's referred to the computer and software responsible for communicating with the field connection controller, which is RTUS and PLC, and include the HMI software running on operator workstation. Uh, Thirdly, to increase the integrity of system, the multiplier will often be configured in a duo, redundant or hot standby formation, providing continuous control and monitoring in the event and then server malfunction or breakdown. And then we can see, as we know, this is RTU. RTU is a terminal unit. Remote terminal unit connect to the sensor and actuator in the process and networked to the supervisory computer system. RTU is a intelligent I/O and often have evident control capabilities such as ladder logic in order to accomplish Boolean logic operation. So this then we go to the PLC, or known as programmable logic controller, that are connected to a sensor and actuator in a process and are networked to the supervisory system same way as a RTU. But PLC have a more sophisticated embedded control capability than a RTU, and programmed in a one or more IEC 61131 programming language. PLC are often used in a place of RTU as a field device because they are more economical, verticalized, flexible, and configurable. Next is a communication infrastructure. This connect the supervisory system to the RTU and LPLC and PLC, and may use industry standard or manufacturer proprietary protocol. Both RTU and PLC operate autonomously on in the near real-time control the process using the last command given the supervisory system. Failure of the communication network does not necessarily stop the plant process control, and or resolution of communication can continue with monitoring control. Some critical system with will have a dual redundant data highway, often cable via various routes. Then this is a HMI, or known as a human machine interface. Human machine interface is the operator window of the supervisory system. It presents plant information to the operating personnel graphically in the form of mimic diagram, which are schematic representation of the plant being controlled. In many installation, the HMI is the graphic user interface for the operator. Collect all data from the external device, create report, performing alarm, send notification, and many more. Then RTU, or known as remote terminal unit. A remote terminal unit is a microprocessor controller electronic device that interface objects in the physical world with a Scada system. It is installed at the remote controller that collect data codes the data into a format that transmissible and transmit the data back to a certain station or master. RTU typically has analog and digital input and output. Example of a typical RTU shown here. So this is a RTU picture that we can see, and this is a structure for RTU. Communication architecture, point to point architecture. So as you can see, figure below is the simple method which data is exchanged between two stations. One station is master and another one is a slave. There is some protocol for this method such as full duplex, half duplex, or simple duplex. Multi-point architecture. This configuration is generally one master station and multiply slave station as a figure below. The master is in the data control in the data communication. If two slaves want to transfer data between each other, they would do so through the master which uh, which act as aggregator. This one is a different before the others because they have one master one master which act as a articulator. Relay station architecture. This is a store and forward. This can be approached with is one station retransmit message to another station out of the control for of the master station. As the below, RTU number 4, known as this, store and forward the message from the master and to the RTU 5. So from here and to here. Relay station architecture. Talk to repeater. This is also one of above method, and it is a way of increasing the throughput of a system. A device called a repeater retransmitted signal receives stimulus on another frequency as in figure below. However, there is a slight time delay in the transmission of data with a repeater. A repeater will design with lead time in mind. So this is a repeater that I've shown. Uh, Next is example in oil and gas. The objectives of Scada in pipeline gas monitoring are as follows: link all site nodes to central station, use a monitoring or and controlling the facilities. The physical link at the facilities is via remote terminal unit RTU to the field device. Capable to close the main valve and control the set point of a compressor station. So this is another example in oil and gas. Typical function use firstly data telemetry, secondly system control that allow remote control command, forecasting provided plot and translog info on alarms and commands, record keeping log achieved for historical purpose, information provider, schedule and on-demand report generation, simulation and optimization, calculation of line pack, pressure profile, and valve statutes. So this is a example of SCADA in pipeline monitoring, and as you can see, so there is a comparison between DCS and SCADA. DCS is a closed loop control in limited geographical area, and then is a one implement the plant cannot One